We're talking about job creation for a whole class of folks that don't necessarily need a degree to participate in this autonomy-driven hardware economy. You know, people are building physical things again. It's really exciting to see. And that's going to require this full stack skill set of people who can kind of cross the hardware software chasm. So I think, we've really seen over the last 2 decades a mass migration of engineers to the sort of software and computer industry. And what I think we're going to see is huge demand for engineers in areas that are much more hardware focused. So things like electrical engineering, mechanical engineering, controls engineering are going to be in really high demand over the coming year as industries from defense to industrials, manufacturing, even things like HVAC and water treatment are looking for people that are really ready to kind of wrestle with and bring AI software into these really complex hardware contexts.
Over the last few decades, we have seen a lot of people migrate to software, and now maybe we're seeing a shift. Can you speak to the macro trends that are really underpinning that?
The last 20 to 25 years has really been the software is eating the world, not to steal our own tagline, but it's really true. Most of the growth in the economy came from the software industry. So with first the rise of software as a service, and then more recently, the kind of explosion of AI, the skill sets that have really been in demand have been software focused. But with the kind of very recent crossing of the chasm from software to hardware, there's huge demand for engineers that kind of can both speak software and speak hardware.
Yeah, and as we do kind of feel this pivot back, are you seeing that in the data when it comes to the degrees that people are getting? Are people no longer getting software engineering degrees at the same clip and maybe choosing to take a mechanical engineering degree, for example?
We're not seeing that necessarily yet in degree programs, but we're seeing that in the demand in companies. And so I think that that's going to filter out into what people end up studying in school. So the highest demand jobs in our portfolio today, other than perhaps AI engineers, are people who have full stack hardware and software experience, whether it's mechanical, electrical, et cetera. And what we're finding is that actually those companies are having to go outside of kind of traditional tech feeder schools in order to find that talent. So we're actually seeing an interesting rise of schools like Georgia Tech, Colorado School of Mines, University of Michigan, some of these like really hardcore engineering programs that really focus on hardware focused skills. Coming into talent pipelines for some of our sort of top tier tech companies in the portfolio, which is really interesting.
So interesting. And let's actually touch on that specifically, this idea of us needing all of these new kinds of engineers. Some of them previously existed, but there seems to be a gap. And there's this question of who's going to train these people. Is it the 4-year degree program? Is it something different?
There's definitely a spectrum. And I would frankly really credit Elon Musk, both from the SpaceX and Tesla perspective, with a lot for really training up engineers that have fluency in hardware and software. As more companies that are building physical things grow, we have a number of them are in our portfolio. Companies like Skydio and Anduril and others are really taking on that mantle and training a new generation of full stack engineers that are really comfortable and fluent across hardware and software. I do think the university systems or some sort of education system has to catch up. Mm-hmm. I expect that schools like Stanford and MIT have great engineering departments outside of computer science programs. I'm hopeful that those programs will continue to grow as the demand in the market continues to grow. And then I also think it's not just engineers with 4-year degrees that are going to be valuable. Like we're talking about job creation for a whole class of folks that don't necessarily need a degree to participate in this sort of autonomy-driven hardware economy. Technicians who will help, service and test robots on the manufacturing floor. Like that is a well-paid, secure job of the future, I think. Another example that we're really excited about is robotic teleoperation. So, you have someone remotely operating a robot in an environment where maybe it's dangerous or hard to get to, or just really difficult to staff humans. It's really difficult doing robot teleoperation. It's a valuable skill set. I expect that there'll be an entire kind of class of jobs related to that arising over the next few years. And again, that's an example of something you don't need a 4-year degree to get really good at robot teleop, but it's a very valuable skill if you do it.
Yeah, and there's no current university degree that would offer
Precisely.
that,
Yeah,
right?
precisely.
Are there any other jobs, new jobs, that stand out that maybe we don't even see quite yet?
Sure. Yeah. I mean, I think that when you look at, for example, the recent results that came out about the TSMC factory in Arizona, there's a whole class. The Governor Katie Hobbs has introduced this big apprenticeship program where they're helping to train new semiconductor manufacturing employees alongside folks who have come over from TMC. So I expect there to be, with kind of the rollout of the CHIPS Act, I expect as chip manufacturing comes back to the US, that it's an entire class of jobs that we just have literally never had here. Maybe we did for like 5 years in the 60s, right at the beginning of the industry, but it's not a job that's existed in the United States for many decades. And I expect reshoring will see a lot of those coming back. I think another example, more in the industrial sector, is you have lots of industries that hired people when they all kind of modernized roughly in the 80s. So there's a large class of, it's oil and gas, it's water treatment, it's chemical engineering and HVAC. There's kind of a class of these heavy industries that introduced a lot of new equipment and new ways of operating in the late 80s, hired a whole bunch of people to work on it, and then essentially never really had to hire anyone else after that. They're great jobs. There's low turnover. They're well paid. And now we're seeing kind of mass retirement across some of these heavy industries and companies really looking to incorporate more autonomous kind of control systems in the way they manage some of these processes, but there's no one to operate them. So what does the next generation water treatment engineer look like? It's someone that knows their way around a robot, a control system, a PCB board. They're going to have to know their way around sensor data, and they're going to have to be able to understand how all of that integrates together to be able to troubleshoot when things go wrong. So huge opportunities in some of these industries where we're just seeing, massive labor gaps over the coming, 3 to 5 years.
Wow. And that's pretty soon, actually.
Yes, it's happening now.
Yeah. And so that sounds like an incoming shortage. Are there any other shortages as we think about the supply and demand? Maybe not so much of completely new jobs, but existing jobs.
The thing that really stands out in our portfolio, especially when you look across industries like aerospace, defense, robotics, it's this notion of a full stack engineer. And I don't mean a full stack software engineer. I'm talking about a full stack hardware engineer. So someone that can write some code, they can write some firmware, they can fiddle around with electronics, maybe design a really simple sort of PCB board with components, figure out how it fits in a mechanical system, sort of troubleshoot when things go wrong. There are just very few people who have that kind of end-to-end skill set. And many of these industries are still relatively early on their robotics or autonomy journey. So there's still a lot of iteration to go around. Things aren't fixed in time. So the biggest demand that we're seeing in our portfolio is that fluency across multiple different domains that includes hardware or software.
Fascinating. And as we think about closing that gap, right, producing more of these people who are full stack in the hardware sense, what do you think is needed? And let me preface by giving the example of, we saw this wave of software engineers over the last few decades, and that was pulled by the market in many senses. And then you also had these large companies like the FANG companies providing a lot of really impressive benefits, right, for these people to come in. Do we need the same kind of, you could say, marketing to influence the larger system, or do you think the market will just kind of make it up for itself?
I think a lot of it will be market driven. It's about capitalizing on this sort of romantic desire to build stuff that I think is in the air right now. So how do companies take the magic that happened when we all got up at 5 a.m. and watched SpaceX catch a massive multi-story rocket with chopsticks in the air? Like, that's so cool. And I think the companies that can figure out how to translate that feeling into, pulling people who might otherwise go down a safer route of, I know I can go get a really big paycheck at one of these research labs. I think it's up to these companies that are building in these hard and gritty spaces to pull that talent and inspire people to really get into the guts of like, what does it mean to deploy a model on a physical system, and what is the complexity and challenge in that? I think it's like capturing the lightning in a bottle that exists kind of in the moment right now, and turning that into early movement from the pure software or pure AI industries. We're already seeing this some with the like larger robotics labs that have gotten well funded over the last 12 months or so. Companies like Anduril and Waymo and Skydio and others are pulling incredible talent still. That's going to hopefully translate into more and more 18-year-olds being inspired to take a mechanical engineering class or build a robot. It's really important that we figure out how to build things again in the United States at scale in production. And I don't think that's going to happen with the way sort of labor economics work globally. If a huge part of the way we manufacture in the future is not driven by autonomy. And it's kind of a chicken and egg problem. Like, we need the robots to build the factories, and we need the factories to build the robots, because right now all the components for robotic arms, everything that might go into an autonomous factory is all coming from Shenzhen.
Right.
So how do we start kind of bootstrapping this supply chain native to the United States, or, the US and our allies, so that we're less kind of fundamentally existentially reliant on another power? So we have to start somewhere. And I think it's going to take people who really want to build and get stuck in and are willing to just kind of tackle that problem kind of vertically head on to do it, to really own the kind of end-to-end supply chain for birthing something into the world. And I think we need more of that in founding teams.